Hello, a good day to you, my dear students. In this video, we will be discussing on solving problems involving linear functions, which was taken from the module titled Application of Linear Functions by Miss Chriselle A. Laderas. At the end of this video, you are expected to solve problems involving linear functions. But what do we mean when we say linear function? It is described by the equation y equals mx plus b, which is also known as the slope-intercept form of a line, wherein m and b are real numbers and the exponent of x must always be equal to 1. Or it can be written as a function notation in the form f of x equals mx plus b. Let's now proceed to our lesson, solving problems involving linear functions. Now, you would not imagine how often linear functions are found in our everyday lives. Linear functions can be represented by a table of values, a graph, or an equation. Now, we will solve real-life problems by translating them into any of the representations of linear functions. Let us have examples. First example. Plants absorb carbon dioxide and they convert it into life-empowering oxygen for us to breathe. Adding cactus and succulents to your home helps keep your air fresh and remove toxins from the environment. Maria receives 200 pesos a day as a garden assistant and an additional 10 pesos per plant that she sells. Questions? First, write an equation that relates the amount Maria is paid to the number of plants sold. Second, how much does Maria earn if she sells 5 plants in one day? 15 plants in one day. Third, if she is paid an amount of 300 pesos, how many plants did she sell? So to solve those questions, we have to consider first the problem. Maria receives 200 pesos a day as a garden assistant and an additional 10 pesos per plant that she sells. We have to write first or find the function that relates the amount Maria is paid to the number of plants sold. So considering now the number of plants Maria sells in a day and the amount Maria is paid in a day, we have to determine now the dependent and independent variables represented by the variables x and y. Take note, the independent variable, it can stand alone. It exists even if the dependent variable does not. While the dependent variable, it depends on the independent variable. So the independent variable is represented by the variable x and the dependent variable is represented by the variable y. So let us now represent. We have to let x be the independent variable, and considering the number of plants Maria sells in a day and the amount Maria is paid in a day, x is the number of plants Maria sells in a day. So of course, Y is the amount Maria is paid in a day. The amount Maria is paid in a day depends on the number of plants that she sells. Since we already represented the dependent and independent variables, we are now ready to find our working equation, which is in the form y equals mx plus b. So we have the equation y equals 10x plus 200, or f of x equals 10x plus 200. Take note, we have here 10 as the constant multiplier of x because from the problem we have a condition here wherein it states that she will receive 10 pesos per plant that she sells. So for every plant represented by X, she has 10 pesos. And plus 200 for being a garden assistant. So we have here y equals 10x plus 200. Now, since we already have a working equation, we are now ready to solve for the second and third question. For the second question, we have how much does Maria earn if she sells 5 plants in one day? Now, looking back our representation, X represents the number of plants Maria sells in a day. And for this question, we have the number of plants sold in a day, and that is 5. So in here, X equals 5. So using our working equation, we have Y equals 10x plus 200. Since x equals 5, we now have to substitute 5 to the variable x. Therefore, we have y equals 10 times 5 plus 200. And 10 times 5, that's 50, plus 200 is 250. Therefore, y equals 250 pesos. Take note, in solving problems, do not forget to write the unit. Thus, Maria earns 250 pesos in a day for selling 5 plants. 200 pesos for being the garden assistant, and an additional 50 pesos for selling 5 plants. How about for selling 15 plants in one day? So again, here we have x equals 15. So using our working equation, we have y equals 10x plus 200. That's our linear function. By substituting x by 15, we now have y equals 10 times 15 plus 200. 10 times 15, that's 150, plus 200 is 350. Now, since the question asks how much, then we have 350 pesos. This means that Maria earns 350 pesos in a day for selling 15 plants. Next question. If she is paid an amount of 300 pesos, how many plants did she sell? Take note for this question, the given is the amount Maria is paid in a day, and that is 300 pesos. So y is equal to 300. Now, using our linear function, we now have y equals 10x plus 200. By substitution, y now becomes 300. equals 10x plus 200. Then, to get rid of 200 on the right side of the equation, we have to subtract 200 to both sides of the equation. So, we have 300 minus 200 for the left side and 10x plus 200 minus 200 on the right side. Simplifying, we have 300 minus 200, that is 100. And 200 minus 200 is 0. Or we can cancel 200 and negative 200. So we have 10x on the right side. Now, since we are looking for the value of the variable x or the number of plants Maria sells in a day, then we have to get rid of the numerical coefficient of x, which is 10. And that is done by dividing both sides by 10. So we have now 100 divided by 10 is equal to 10x divided by 10. 100 divided by 10, that is 10. And 10x divided by 10, cancel 10. So we have x. So 10 equals x or x equals 10. So we have 10 plants, which means Maria sold 10 plants for earning 300 pesos in a day. Next example. Parking along major roads and streets in some places is often limited. Thus, owners of private lots surrounding the central business district area and private higher education institutions have been offering their open spaces for pay parking services to help reduce the traffic jams along major streets. At a paid parking area, a driver pays an initial amount of 50 pesos plus an additional 20 pesos for every hour of parking. If the driver parked for 4 hours, how much will the driver pay? If the driver paid 190 pesos, how many hours did the driver park? So again, we have to consider the problem. At a paid parking area, a driver pays an initial amount of 50 pesos plus 20 pesos for every hour of parking. The two variables here are the number of hours of parking and the total amount paid at the parking area. Most of the time, the amount to be paid is the dependent variable because it depends on something. We are paid because of something we give or offer. So in this case, the independent variable is the number of hours of parking and the dependent variable is the total amount paid at the parking area. Therefore, if we're going to represent the problem using a linear function, we have y equals 20x plus 50. The initial amount here is 50 and the constant multiplier of x because from the problem we have 20 pesos for every hour. So we have to multiply 20 for the number of hours of parking. Moving on to the first question, if the driver parked for 4 hours, how much will the driver pay? Take note, from the given, we have 4 hours and the number of hours of parking is represented by the variable x. So we have x equals 4. Using our linear function, we have y equals 20x plus 50. By substitution, we now have 20 times 4 plus 50. And 20 times 4 is 80 plus 50 is 130. And of course, for the unit, we have pesos because the question is how much. So y equals 130 pesos. That means the driver will pay 130 pesos for parking for 4 hours. Next question. If the driver paid 190 pesos, how many hours did the driver park? So for this question, the given this time is the variable y, which is equal to 190. Again, using the linear equation, we have y equals 20x plus 50. By substitution, we now have 190 equals 20x plus 50. Next, since we are looking for the value of x, we have to get rid first of 50. And that is done by subtracting both sides of the equation by 50. So 190 minus 50, that's 140. And 20x plus 50 minus 50 is 20x. Now we have to divide both sides of the equation by 20. So we have 140 divided by 20, that is 7. And 20 divided by 20 is 1. 1 times x is simply equal to x. Therefore, 7 is equal to x or x equals 7. Now, since we were asked on how many hours did the driver park, so we have the unit hours. So, x equals 7 hours, which means the driver parked for 7 hours. Next question. Due to the pandemic, traveling locally as well as internationally may have travel restrictions in place. Make sure to check up-to-date information and travel guidelines where you are going. Let's say we are going on a trip where we are averaging a speed of 65 kilometers per hour. How far can we go in 5 hours? How long will it take us to travel a distance of 455 kilometers? So this time, we are dealing with the distance, the rate, and the time. So for our representation, we have to let D for the distance, it's the product of the rate or speed and the time, and R for the rate or speed, and T for the time. Now, since the distance is the product of the rate or speed and time, we now have the equation D equals RT. So since we already have the equation and representations, we are now ready to answer the questions. First, how far can we go in 5 hours? Take note, the given there is 5 hours. It's the time. Therefore, t equals 5. And using the equation, we have d equals 65t. So by substitution, we have 65 times 5, that is 325. Since we are asked of how far, so the unit should be in kilometers. Therefore, D equals 325 kilometers. That means we have traveled a distance of 325 kilometers after 5 hours. Next question. How long will it take us to travel a distance of 455 kilometers? Take note, the given here is the distance. So we have d equals 455. Now, using again our working equation, we have d equals 65t. By substitution, we now have 455 equals 65t. Dividing both sides by 65, 455 divided by 65 is 7, and 65 divided by 65 is 1 times t, we have t. Therefore, 7 equals t, or t equals 7. Since we were asked of the time, so the unit is hours. Therefore, t equals 7 hours. It will take us 7 hours to travel 455 kilometers. Last example. Vocabulary is the basis for learning language. Vocabulary development does not stop once a child can talk. In fact, children learn many new words once they start reading and going to school. The number of a child's vocabulary is a function of the child's age. Thus, the size of vocabularies of typical children between the ages represented by small letter a of 20 months and 50 months is given by the equation f of a equals 60a minus 900. How many words does a typical 25-month-old child know? How many words does a typical 50-month-old child know? So since from the problem, given already is the working equation or the working function, we have f of a equals 60a minus 900. So to solve for the questions, we simply have now to substitute values for a. For the first question, how many words does a typical 25-month-old child know? We have A equals 25. Therefore, using our function, f of A equals 60A minus 900, f of 25 or the function at 25 is equal to 60 times 25 minus 900. And 60 times 25, that is 1,500, minus 900 is 600. Therefore, a 25-month-old child knows 600 words. Next question. How many words does a typical 50-month-old child know? For this question, we have A equals 50 because the child is 50 months old. So using our linear function, we have f of a equals 60a minus 900. We now have to substitute 50 to the variable a. So we have f of 50 equals 60 times 50 minus 900. 60 times 50, that is 3,000, minus 900 is 2,100. So a typical 50-month-old child knows 2,100 words. That's all for our discussion on the application of linear functions in real-life situations. But before we end this video, always remember to solve problems involving linear functions, you can follow the steps. First, translate the problem statement into a mathematical statement. Second, identify the unknowns in the problem and assign variables to represent unknown quantities. Third, read the problem thoroughly and organize the information obtained sequentially. Fourth, formulate an equation and solve it using systematic techniques of solving equations. And last, Check your solution to the problem statement and analyze if it answers the problem. That's all. I hope you have learned a lot from this video. Thank you for watching.